In this video, we're going to talk about functions. What is a function, what a graph of a function is, odd and even functions, and increasing and decreasing functions. There are many examples of functions in the world around us. The level of blood alcohol, as it depends upon time, the area of a circle as it depends upon its radius, or even the number of different species inhabiting an island is a function of the island area. We define a function as follows. We let D and E be sets. A function f is a rule that assigns to each element in D exactly one element f of x in E. The function f eats x and it spits out some value y. So D is called the domain of f. The range of f is all possible values of f of x as x varies throughout the domain D. So graphically, here's D, and here's E, and the function takes some value x in D, and it maps it to f of x in E. The graph of a function is a set of all ordered pairs x, f of x, where x is in the domain. We normally think of D and E as sets of real numbers, and then the graph of f just consists of all the points x, y in the coordinate plane such that y is equal to f of x, and x of course has to be in the domain of f. So if these are the coordinate axes, the graph of a function is drawn here. I haven't given a formula to it, but it's the set of all points x, y such that f of x is equal to y. There's a vertical line test to see if we really have a function. Any curve in the xy plane is a function if and only if no vertical line intersects the curve more than once. So we see three examples here. The two on the outside are functions and the one on the inside is not a function. So curve in the xy plane is a graph of a function if and only if no vertical line intersects the curve more than once. Now we see the example in the middle. If we drew a vertical line, it could intersect twice. So this is not a function. The ones on the right and the left are functions. The formula for the function on the left is f of x is equal to the absolute value of x, and the formula for the function on the right is f of x is equal to the square root of 1 minus x squared. We see that it's the top half of a circle. The domain on the left is all real numbers, or we could also write that as open interval minus infinity, infinity. The domain on the right is x is a real number such that minus 1 is less than or equal to x is less than or equal to 1. Now the range on the left is x is a real number such that x is greater than or equal to 0. We could also write that as 0, infinity interval. You don't need to write it using both notations, but I'm just showing them here. On the right hand side, the range is x is a real number such that 0 is less than or equal to x is less than or equal to 1. So I could also write that using interval notation as interval 0, 1 with closed brackets. There are properties of functions we'd like to be able to talk about, such as whether they're even or odd. If a graph has symmetry with respect to the y-axis, such that f of minus x is equal to f of x, then it has even symmetry. So here, f of minus x is the absolute value of minus x, which is equal to the absolute value of x, is equal to f of x. So we've mathematically shown that there's even symmetry. On the right hand side, f of x, I should say f of minus x, squeeze the minus in there, is the square root of 1 minus x squared, which is equal to the square root of 1 minus x squared, which is equal to f of x. Similarly, we can have odd functions. The graph on the left is f of x is equal to minus x, and the graph on the right is f of x is equal to x cubed. The symmetry is odd if there's odd reflection around the y-axis, i.e. f of minus x is minus f of x. So here f of minus x is minus x, which is equal to x, which is equal to minus f of x. And on the right hand side, f of minus x is equal to minus x all cubed, which is equal to minus x cubed, which is equal to minus f of x. A function is called increasing on an interval if whenever x1 is less than x2, f of x1 is less than f of x2. And it's called decreasing on the interval if whenever x1 is less than x2, f of x1 is bigger than f of x2. So if we take a look at the function y is equal to f of x, we see that it's decreasing on the interval minus infinity 0 and increasing on the interval 0 infinity. In summary, we've talked about what is a function, we've talked about the graph of the function, odd and even functions, and increasing and decreasing functions.